Hey girls, it's Sam and Donut. We are going to be teaching you about linear functions. Lucky us. If you take out your worksheet that I submitted along with this link to the video, you will see everything that we're doing today and what I'm going to talk about. So take that out and you can follow it. McCray, thank you. Okay, McCray's very excited I'm recording and is going to be throwing Donut into the screen whenever he can. All right, if you look at what we're talking about today is linear functions. Now, linear functions are defined as functions that grow into a linear or constant manner, which means that they grow into a straight line, linear line. By graphing these points and seeing that the points are on a line, it allows students to connect that information and to see them in a very visual way. Okay, so graphing is the best way to teach linear functions because students actually physically connect the dots, they see the correlation, and all of that. Okay, so on your worksheet you also see a graph that I included for you, but a little quiz of what I've already told you about. Looking at these two graphs, which one would you say would be the linear? A or B? Well, if you picked A, you'd be right. As you can see, the straight line dictates the linear. Remember, line is important. Linear line. Okay? All right. So, as you will see on your worksheet that is also included, you also have a very perfect example of that. A linear is a straight point line. Now, one of the most important sections of my section was mathematical modeling. Okay, so what is modeling? It's the process of beginning with real phenomena. You will see that phenomena is for like rules and how things follow a certain way. So instead of saying rules, it's called mathematical or real phenomena. Okay, mathematical methods or equations are used to predict other mathematical phenomena. So these are all different things that are found in and around linear functions. So what is modeling? It's taking all of these things and trying to construct it and put it into a set order. We're taking all these things that a lot of kids don't understand how they make sense, why they make sense, and trying to pull it down. So why do we model? It allows us to take all of these theories of how things work and put them in an equation or a formula to help the students predict future changes. Okay? By demonstrating this to students, we will show them that equations have a purpose and that they allow us to find values that cannot be observed in real phenomena. There may be another kitty in here in just a moment. They are very interested to see what I'm doing. Okay? So, mathematical modeling is how we take ideas that are outside and we bring them into the classroom and we give them a structured way to enter our classroom. So, I'm going to do a little mathematical monitoring with you. Okay? So, for the example we'll be talking about, it's McCray, I'm sorry. Go away. That's Duncan. She says hi. Our first example is going to be the depreciation of a car percentage over each year. So every single year your car depreciates in value, and this car depreciates in value at 20% each year. Determine how the model might progress in the following steps. Okay? So if the car loses 20% of its value after a year, how much value is it going to have after a year? Well, how would we do that is we would set up a formula by this, okay? So the value of the car as of right now is $15,000, okay? It's $15,000 and it's 20%, so we're gonna multiply it times 0.08, okay? So that's our basic formula to figure out for 1 year, okay? Our answer for 1 year, how much it depreciates in value, is $12,000 is how much our car is worth. So we bought it at 15, it's now a year later, and our car is now worth $12,000. Okay? So we have this formula of 15,000 times 0.08. Okay? So a year passes, we want to figure out the value for this next upcoming year. So we take $15,000. Okay, we times it by 0.08. Okay, now would that be suitable to figure out for the second year? No, it would not. You would need to multiply it times another 0.08. Okay, So, because this is for year 1, sorry, I can't figure this out. This is for year 1, this is for point year 2. Okay? If we do the math, we realize that after the second year, our car is only worth $9,600 after the second year. So our value is, all right. So we have this formula, which doesn't seem to be working too well. Just keep adding. There's a better way we can do it. And the better way we can do it is by using exponents. Okay? So a simple exponent means we dictate that it gets multiplied that many times. So if we wanted to rewrite this to make more sense for the second year, what we would do is 15,000 times 0.8 squared. Okay? All right. So we have gone through the process. We figured out that the best equation looks like this. Now, what we're trying to do with linear functions and what we're trying to do with modeling is we're trying to show that there is a reason for all mathematical phenomena. So the best way we can teach our kids is how to use this in an equation. What is the best way to dictate an equation or an unknown factor? That is our good friend y. So by using a y instead of a 2, we leave this wide open for interpretation. Okay, so our new equation takes us 15,000 times 0.8y. Okay, this is our brand new equation. Now take that equation. How much worth do you think our car is going to have after 10 years using this equation? Please do that now. Do 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 do.
Don't almost give me
Do 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 do. All right, so after 10 years, how much value do we have using our formula? We have $1,610 after the 10th year of owning this car. Not good. Anyway, so by using our system, by using our equation that we created, we can find out for how many years, whatever year we want. If we want to figure out how much it's worth in 20, it's not going to be looking good, but we could figure it out. Okay? There we go. All right. So if you noticed, I never included the rule for this equation. We don't use rules anymore. Okay? We're teaching kids to think for themselves. So for them to think of this in rules and by structures, it doesn't give them the creativity to see outside the level. All right. So when you're teaching linear functions, there's a bunch of things you really need to keep in mind. First thing is that you need to use the appropriate vocabulary. Just like if we were teaching reading, we want to use words that dictate to the level of our students are reading at. We want to push them up. We want to continue to support them. Just like this in math. How can we expect our kids to use the language and to understand language when we don't use it ourselves? Okay? A large part of understanding mathematics is the ability to communicate it mathematically. So it's important to use these terms throughout the class continually. And when I say continually, it's not just having them write down the definition and be done with it. It's constantly using the words, having a word wall, keeping a journal of the terms, graphs and models that are fully identified so the kids have an ability to reference the definition, what it looks like, in order to make a memory marker. Okay. When you are teaching linear functions, some important terms are independent and dependent variables, discrete and continuous, and domain and range. Another major teaching consideration that you need to have is multiple representations. Now, I am a struggling math student. I do not learn well unless I'm showed math in many different formats and many different structures. So what does multiple representations means? It's meant that we can show what the equation is stating or what it means or what it looks like in many different ways. Now this could be the pattern, this could be a table of the information, a verbal description of the information, a symbolic equation, or a graph. So by using these different ways to demonstrate the content, we are reaching our students in different ways. Some of them are the audio learners. Some of them are the visual learners, and either or, they're hearing the content in different ways and they're more likely to retain it. Finally, connect representations. If we just show kids graphs all the time and we don't show them the equations that go with the graphs, then how can we have them understand those connections between this graph is representing this equation? We have to make sure we tie everything together, and so they understand that they see different things at different levels, and that they, in fact, everything does come together. Because in the end, with math, in the end, everything comes together. It's important that students should be able to explain the connections across representations in a conceptual manner. So if we use manipulatives, if we use fractions, if we use manipulatives, if we use graphs, and we use equations, we need to tie them all together so they all make sense. Finally, algebraic thinking across the curriculum. Now, the new trend in math is not to teach things in geometry or not to teach things in algebra, that all of these concepts that are found in geometry and those that are found in algebra are covered across the entire spectrum. So we want people to think of looking for patterns and generalizations, go beyond just thinking about algebraic equations and linear functions. So we want to have kids think about things on different levels outside the box. All right? Well, that was my big section. A lot of great ideas. If you have any questions, I will be back next week, and I'll be happy to answer anything you have. If not, you can feel free to ask me questions on YouTube. I will not answer them, but you are more than welcome to do it. And I hope you had a wonderful time watching me make a fool out of myself on this. And ladies, I look forward to seeing you rowing after my boat. Mwah! Have a wonderful, wonderful week, and Donut wants to say goodbye. Perfect. Bye. Hey, Ashley and Kelly. I just wanted to say hey and just get started on my lesson for today. Now, please stop laughing. I am trying to be as serious about this as possible. So anyway, here we go. We are talking about linear functions today. Very exciting stuff. So if you take out the worksheet that there's Donut. She wanted to say hi. Anyway, so let's get going. If you take out the worksheet that I submitted with this address to this email, take it out and follow along with me. McCray, get her out of here. McCray, this...
Happy believer. Okay.